Another material property will be abradability. And I will ask Martin, can you introduce this? It's all related to surface properties and the way how the surface will be. Every material basically tear down after while because of the loading and brushing when people walk on these stairs. So, and once we will use this product, our product as a flooring system, it can be used also for stairs, it can be used for the decking or for some flooring system. It also is conducted or sustained to such load, so that's why we choose also this abradability. Okay, Martin, you probably know Martin, some of them. So I don't need to tell you.
Quite a lot has been already explained, so this is going to be very brief and quite simple. And so principle actually was partly explained. So we actually want to determine a loss weight of that piece, which will be obtained by measuring the weight before and after the abrasion. Basically, in other words, you can imagine that we want to reduce certain amount of mass from the sample, and before we actually measure it, and then at the end we also measure that reduction of the mass, and then we actually put it in the equation, and we get the result, like how much actually this particular material which will be our sample can actually resist to losing the mass during the test. And we also can measure radial, tangential, and crosscut surfaces, which also are different because of the structural group. This is the machine that we will use. I just took a picture of that. So you can see these are the samples in the upper picture. It's like a small cylinder or certain diameter. So these are the samples, and this is the kind of head where those samples will be placed, and then there is a certain mechanism of the machine. This is actually the cylinder. Which is important because there will be wrapped on or around a sandpaper of certain grain. I think it's like 100 grain, and it's rotating during the test. So in the same time, also this head is moving left on this 2-feet belt. So actually, the sample is moving and the cylinder is rotating. So actually, it's always like taking another trajectory or trajectory of the sandpaper, and it goes just it's boom, 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 like you see. I'm not totally sure like how many rotations, or maybe we will like measure time or rotations of the cylinder. It doesn't take more than 1 minute to get from one end to the another. So this is kind of like principle of the whole test. And then we have some calculation. The indicator T is calculated with following equation. Either we can express it in a number, or we can put a percentage of the result. And it's very simple equation. It's just mass before, as I said, and minus after. And here actually it's a mistake, sorry. It should be M1. And divided by the weight which was at the beginning. So we can see the meanings of the marks. And we measure accuracy. The measurements will be the accuracy of 0.05 grams. So that's probably all for this test, I would say. If anybody has any question, like, we'll be glad to explain it. Thank you.
One question.
How frequently do you need to change the paper, the sandpaper?
That's a good question. I think we should use each time new paper for new sample.
For new sample, yeah.
according to those standards.
Use quite a lot of samples for that.
Yeah, we have a good project.
There are a lot of papers also.
Yeah, but it takes, we are assuming that probably one samples will be used for half of the cylinder, and another for another half. Then we will change the sandpaper and do another test. So, and those samples for one group, I'm assuming 5, 6 samples. Just to have idea what's the abradability of the material. Okay, so thank you.